Good day. I am Christian Jan Alado, ID 123, and today I'll be teaching FNDMATH LQ1, which includes equations and inequalities in one variable and partial fraction decomposition. So for our next question, we have find the solution set of the system negative 3x plus 4y equals 2 and 5x minus 2y equals 3. Now, to solve this, this is basically just a simple problem of systems of linear equation. With this, we basically have to manipulate the equations or the system so that we can get the values of the variables. So for this, we have 3x plus 4y, negative 3x rather, plus 4y equal 2, and 5x minus 2y equal 3. Now, if we were just given one variable, let's say we didn't have y here, we can just equate both equations to each other and solve for x. But since we're given with x and y, we have to manipulate the equations so that we can get the value of one variable and then substitute it back, and then get the value of the other variable. Now, to show that, if you did not get that, basically you have to manipulate one equation. In this case, I want to manipulate this equation. So what do we want to do? What we want is to eliminate one variable so that we will be left with one variable only and that we can solve for that variable. So in this case, what we can do is multiply this equation by 2. What this would do is it would give us negative 4y, and when we add it to this equation, it would eliminate y and we'll be left with x. Now, I'll just show you. That would give us negative 3x plus 4y equal 2, and 5x, oh, never mind, multiplied it by 2. That would give us 10x minus 4y equals 6. Now, what we want to do is add the equations to each other. That would give us with 7x, this would cancel, which is what we wanted, equal to 8. Now we just have to eliminate 7, or the constant 7, from x so that we can have the value of x. So with that, we multiply both sides by 7, and that would give us with x equal to 8 over 7. Now, if you look at the choices, we can already say, the answer is D. But I'll just show you how we can get the value of y as well. Basically, we just have to substitute x to any of these equations. So I choose to substitute it here in the first equation. So that would give us with negative 3 multiplied by 8 over 7 plus 4y equal 2. Now, we just have to multiply this, which would give us negative 24 over 7 plus 4y equal 2. Transfer negative 24 over 7 to the right side, which would leave us with 4y equal to plus 24 over 7. Add both of them together. We can just multiply 2 with 7 over 7, which would give us 14 over 7 plus 24 over 7, which would give us 38 over 7. Now we're left with 4y equals 38 over 7. Now what we want to do is divide both sides by 4, which would give us with y equals to, since 38 is not a factor of 4, or 4 is not a factor of 38 rather, we can just divide it by 2. So that would give us 19 over 14. And as we can see, D is the correct answer. Let me circle it. D is our correct answer. Now, for the next question, here we have another partial fraction decomposition problem. So we're being asked to find the value of b, and we've already been given with the decomposed fractions. So what we just want to do is basically do systems of linear equation so that we can solve for the values of b, or any constants in that case. So what we can do is first we have to eliminate the denominator, right? So to do that, we basically have to multiply both sides by x squared minus 2 and x plus 2. Oh, sorry. Okay. Now, we have here x squared minus 2x plus 8 all over x squared minus 2x plus 2 equal ax plus b over x squared minus 2 plus c over x plus 2. There. So basically, we have to multiply both sides by x squared minus 2 and x plus 2. Now, multiplying these to this would cancel our denominator, which would leave us with x squared minus 2x plus 8 equal to, if you multiply this with this, that cancels x squared minus 2, which would give us with 8x plus b multiplied by x plus 2 plus c. Multiply this to this, which cancel x plus 2 and give us x squared minus 2. Now, in this case, you can choose to distribute for less confusion, but I'll show you a slightly shortcut way, which in this case, we don't have to distribute anymore. Now, what we want to do is get the coefficient of each degree and the constant. So what do I mean by that? Let's say we have here x squared, and we have here an x, and we have a constant. So for x squared, we basically have to get the coefficient of x squared in both sides of the equation. So that's for example, here for x squared, we have the coefficient of this is basically just 1, so that will give us with 1 equal to. Now, the reason why I said we don't have to distribute is because if we distribute this, that would just give us with ax squared, which is the coefficient of the x squared, which is what we want. So basically, that would give us with a here. And for this, if we distribute it here, that would give us with c. So basically, we just took all the coefficient of x squared, which is a and c. It can't be b, since if we distribute b here, it won't give us bx squared or anything like that. So it's just a and c. Next, for x, we have here negative 2 equals to here. We can have a, right? Since if we distribute it here, that would give us with 2ax. So that would give us 2a. And for this, we have b. Lastly, we can have it for c since we don't have an x here. So we'll go for the constants. There. Negative 2. Yeah. So the constant here on the left side is 8 equal to, here it can't be a since a has x attached to it. So it's b. So that's 2b plus or minus 2c in this case. Now, what we want to do, once again, is manipulate the equation so that we can get the value of one variable and then substitute that variable or that value to the other equations so that we can get the value of the other variables. So in this case, we can use we can basically use the equations for constant and x squared, right? So how do we do that? So basically we have here 1 equal a plus c, and then 8 equal 2b minus 2c. Now, what we want to eliminate in this equation is c, right? So how do we do that? We do that by the same way we did with other problems, in which we multiply one equation with a value so that we can cancel one variable. In this case, we can multiply the first equation by 2 so that we can cancel c. So that would give us with 2 equal 2a plus 2c and 8 equal 2b minus 2c. Next, what we want to do is add both equations. That would give us with 10 equal 2a plus 2b. Cancel this. Now we can use this equation then with our equation for x so that we can solve for b. Now, to do that, we have -2 equals 2a plus b, and 10 equals 2a plus 2b. Wait, I'll just interchange both so that we won't get confused here, and move it up. There we go. So for this, we now want to subtract both. Since if we add, we'll just get we'll just get larger values of a and b, right? But if we subtract, we can eliminate a in this equation and get our value of b. Now, 10 minus -2 is 12, right? Since plus plus and then this negative and this negative and this minus, right? So this can equals to this cancels. And for this, 2b minus b is just b. And that would give us with 12. And that answer is letter D. Now, if you want to solve for the other values of the other coefficients or variables, we can just equate or substitute b, let's say here first, right? So if you substitute b to this, that would give us with -2 equals 2a plus 12, and that would give us with the 14, I believe, and then equals to 2a, and then we just get a. And then the same thing for c, right? Okay. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. And once again, this is CJ from Syntax, paving your way to excellence.